So the first one I want to do is number 1. And I'm really sorry, I don't know why, this has happened before too. When I change something to a PDF, it doesn't print the entire thing, which is really strange. It looked like this, with just an ln in the denominator, x squared minus 1 plus ln. It should be ln of x. So you can go ahead and put an x there. I'm really sorry about that. I don't know why it left that off. There's one other question where that happened, and I'm going to do that one too. It like left a blank where there should have been something. I have no explanation for why the PDF did that. All right, so for this limit question, we're going to start by just trying to plug in 1. So in the numerator, that's going to give us 1 minus 1. So that'll be 0. And then down here, we're going to have 1 minus 1, which would be 0, plus ln of 1, which would be 0. So this goes to form 0 over 0. And so we are going to do the derivatives. So for the numerator, 1 is a constant. That's going to be gone. And so this would be negative 3x squared. And then down here, we'll have 2x. Minus 1 is a constant, so that's gone. And then for ln, that will be 1 over x. And so then we're going to plug in 1 and see what we get. So the numerator will be negative 3. And the denominator, we're going to get 2 plus 1, so 3. And so negative 1 is your final answer. And so the other question where it didn't print the whole way, which was frustrating, was number 3. It should be limit as x goes to 0, cosine of x minus e to the x. It didn't put the e in there. It was just a blank, nothing to the x. So again, I apologize about that. I have no clue why it did that. All right, so if we go to plug in 0, cosine of 0 would be 1. E to the 0 would be 1. So we get 1 minus 1. So that'll be 0. And then sine of 0 is 0. And so we're going to do the same thing as we did in the last question. So the derivative. So derivative of cosine is negative sine. Derivative of e to the x is e to the x. And then down here, derivative of 5 sine is 5 cosine. All right, and then we're gonna try to plug in, oh, I did a copy error there. I'm really sorry. We're gonna try to plug in 0, not 1. So sine of 0 is 0, so this is gonna be gone. E to the 0 is 1, so that'll be negative 1. Cosine of 0 is 1, and then times 5 is 5. So negative 1/5 for that one. All right, and again, I'm going to kind of skip around here. I'm not going to be able to do every single problem, so I made myself a list of ones I definitely want to go over for you. I'm going to try and do like, what I would consider the most important ones for us to go over. So we're going to do number 7. So 7 gives us y equals tangent of 2 pi x minus y. It says find the instantaneous rate of change. That means the derivative at 1, 0. So we're going to find the derivative at this point. And it's going to be implicit differentiation because we have the x's and y's, all jumbled up in there. All right, so derivative of y is dy dx. And then what's my derivative of tangent, guys? Let me throw a question at you guys so it's not just me talking at you. What is derivative of tangent? What is that going to give us? Close, secant squared. Good, there we go, secant squared. So we're going to have secant squared of 2 pi x minus y. So secant squared of all that stuff. And then we're going to chain on the derivative of all that stuff. So derivative of 2 pi x would be 2 pi. And then minus derivative of y is dy dx. So again, derivative of 2 pi x is just 2 pi. It's kind of like derivative of 2x is just 2. The pi is just sort of there. Just remember pi is a value. All right, and so now we're going to plug in 1 for x and 0 for y. So this will give us dy dx equals, all right, if we plug in 1 for x and 0 for y, this would just be 2 pi. So we're going to have secant squared of 2 pi times 2 pi minus dy dx. So let me get out my unit circle. 2 pi is the whole way around. So 2 pi would be right here. Secant means I'm going to reciprocate the x value. So if our x value is 1, if I reciprocate that, I'm just going to get 1. 1 over 1 is 1. And then if I square 1, it's just going to be 1. So this entire first part just ends up being 1. Which is what's nice about the unit circle. You have all zeros and ones there for the quadrant angles. So 0 and 1 are easy numbers to work with. So actually we can basically just ignore that. If it's times 1, it's not going to change. Actually, let me just go ahead and rewrite it. I won't be lazy here. Let me rewrite this here without that 1 in there. All right, and our goal is to find dy dx. So I'm going to add this over. That'll give me 2 dy dx equals 2 pi, and then the 2's are going to cancel. All right, so again, we did the derivative, and then we plugged in the point, and then we got dy dx by itself. All right, the next one I'm going to go over is, what did I have on my list here? I'm going to do number 9. If you could look at number 9. So 9 says write the equation. So I'm going to need a point and a slope for this mess here. 3x minus ln of y equals x to the 4th. And it says at x equals 2. So again, I'm going to need a point and a slope, and the x value is 2. So you did one really similar to this on your quiz. To get the point, we're going to plug in 2 for x, and then to get the slope, we're going to do the derivative. All right, so let me plug in 2 for x. That's going to give me 6 minus ln of y equals 2 to the 4th would be 16. And then I'm going to subtract over the 6. So that'll be negative ln of y equals 10. I'm sorry, I know there's a glare there. Let me try and move this over. And then I'm going to divide over the negative. So ln of y equals negative 10. And then I need to cancel out an ln. So hey guys, how will I cancel out ln? What is the inverse of ln? How will I get rid of that? E, awesome, you guys rock. All right, so this is going to be y equals e to the negative 10th, which is a great number. Don't discriminate. E to the negative 10th is great. It's 2.718 to the negative 10th. Just remember that's a value. It's some number. If you had a calculator, you could type it. All right, and then slope comes from the derivative. So we're going to do the derivative of each of these terms. So derivative of 3x would be 3 minus derivative of ln is rational. So that's 1 over y and then times dy dx equals, this would be 4x cubed. All right, so we're going to plug in 2 for x and e to the negative 10th for y. So this would give us 3 minus 1 over e to the negative 10th, which again, don't worry about that. That's fine. It's a number. Don't let it scare you. Times dy dx equals, if we plug in 2 here, 2 cubed is 8 times 4 will be 32. All right, so I'm going to subtract over the 3. So that'll give me 29. And then I'm going to divide over the negative, so it'll be a negative 29. And then I'm going to multiply over the e to the negative 10th. So I'm going to get negative 29 e to the negative 10th, which again is a fine answer. Don't let it bother you. It's just a value. Just leave it alone. And so this is our point and this is our slope, and all you have to do is put it together into the equation. So y minus e to the negative 10th equals this weird slope, x minus 2. All right, and then I'm just gonna pick a couple of the related rate ones. Again, what am I doing on time? Oh, good, I have enough to do 2 of these related rate ones. I know today was not like super fun and interesting. I know you're not like, here, let me just work all these problems, but you know, I think everybody wants a review for their test, so that's kind of how today worked out. I'm sorry it was not like super fun, but review day is review day. All right, so let's look at number 10. This is about baseball question. So we've got the baseball diamond, which is actually a square. And again, the bases aren't moving. So it's 90 feet on each side. All of these are 90 feet. That's not changing. No one's picking up the bases and running around with them, unfortunately, because I think that would be fun. All right, so batter is running from first to second. So you do need to know a little bit about baseball, that this is first base and this is second. So he's somewhere in between and running this way. The picture's not going to be to scale. He's just somewhere in between first and second and running that way. He's running 25 feet per second. Find the rate at which his distance, the distance between him and home plate is changing. So I'm going to connect him with home plate. And this is the triangle that we want to focus on here. So this side is 90 feet. Again, that's not changing. But since he is running, I need variables for the other two sides. And so they gave us his rate of change. That's going to be dx dt. He is running at 25 feet per second, which I always think sounds really fast. I'm not sure I could run that fast. And that's positive because this x distance is growing. And we want to know dy dt. So how is his distance from home plate changing? That should also be positive. We have to pause at a certain moment. So let me look back here. When he is 30 feet from second base, that is a little tricky. 30 feet from second base would be this distance. So if he's 30 feet from second base, what is x going to be? If this is 30, what's our x amount? Good, perfect, 60 feet. Nice job, guys. If the whole distance is 90, if that's 30, it's going to have to be 60. All right, so then we've got Pythagorean Theorem. And then the derivative. So 2x dx dt, 90 squared is a constant, that's gone, equals 2y dy dt. This is almost exactly like your quiz question with the little boy and the kite. 2's are going to cancel, and then we're going to plug stuff in. So x is 60. Dx dt is 25. Y we're going to have to come back to. And dy dt is what we're looking for. So I'm going to go back to this original Pythagorean theorem and plug in 60 for x. So that's going to give me 60 squared, which would be 3,600. Plus 90 squared would be 8,100 equals y squared. And so let's see, 8 and 3 is 11, 600 and 100, 700. So 11,700 is y squared, and then I am just going to square root that. Please just leave it alone, pretty please. I get nervous when stuff is too simplified because then I'm like, well, where did that answer come from? Please just leave it alone. There's no reason to even reach for a calculator. And then the only thing you need to do is divide that over. And what are our units going to be for this one, guys? Because make sure you put units. I'll have to take off if you don't put units. So what are our units for this rate of change? Good, awesome, feet per second. And so if you totally lose your mind, if you make up an answer and put feet per second, I can at least give you something for the units. So, so make sure that you put them. All right, and then I'm gonna have time for one more here. We're gonna do number 12. All right, so number 12, a conical water tank is being filled with water. This is just like the one that we did in the notes on the first day we covered this. So you've got this, this cone that is being filled with water at a rate of 7 feet cubed per minute. So the cubed is a huge clue that's talking about rate for volume. So it's filling up at 7 cubic feet per minute. So 7's positive because it's being filled up with water. All right, the cone has a radius that is 1/4 the height. So radius is 1/4 height. And it says find the rate of change of the depth of the water. So I'm going to use h for the height of the water. dh dt is our question mark. And it should be positive because the cone is filling up with water. Just imagine that ice cream cone shaped thing filling up with water. And then we have to pause at a certain moment. It says when the depth of the water is 4 feet. So when h is 4 feet. And you actually don't have to draw a picture. I'm not going to grade you on drawing a picture of a cone. You can draw one if you like. And I'm not going to make you memorize the volume of a cone either. I have it printed on the study guide. I have it printed on the test. 1/3 pi r squared h. So real quick pep talk. You're going to have to get through the algebra here before you can do the calculus. There is a good bit of algebra. We don't know anything about radius. We know height, and we're looking for the rate for the height, but we don't know anything about r, and that's why I gave you this. And I'm going to give you that on the test too. Whatever this relationship is, you're going to have to take this and plug it in for r, and I need to see all the steps for this. So it's going to be a little bit of writing. Pep talk, you can do it. It's going to be a bit of writing, but you're going to be okay. All right, so we're going to plug in 1/4 h for the radius. And then we're going to square everything that's in those parentheses. So 1/4 squared is 1/16. H squared is just h squared. And then lastly, I'm just going to multiply these fractions together. So 1/3 times 1/16 would be 1/48 pi, and then h cubed. We have a squared and then times another h, so you'd have h to the 3rd. All right, so you have to get through those, what, like 4 steps of algebra there before you can do the derivative. Actually, it's really only 3 steps because the first I gave you this formula. So it's 3 steps of work. You're going to have to get through that, right? Then we can do the derivative. So dv dt equals, we're going to bring the 3 down, and you can leave it as 3/48. In fact, I'll do that. That reduces to 1/16, but you don't have to. You can just leave it as 3/48 pi h squared. Again, power rule, we dropped a degree, dh dt. And then we're going to plug everything in. dv dt is 7. And h is 4. dh dt is what you're looking for. And again, a lot of that does reduce, but you don't have to deal with it. Again, I get nervous sometimes when the answers are too reduced because then I'm like, where did that answer come from? All you have to do is divide all that stuff to the other side. Just don't do a copy error. And that would be it. And then you just have to put units on. What would be the units for this one? What units would you put for this one, guys? And this one's a little tricky. That's why I want to ask you and see what you guys say. And good, thank you. Nice job, Zach. It is feet per minute. The reason that this is cubed is because it was for the rate for the volume. Nice job, Sophie. Thank you. Feet per minute. This was cubed because it was for the rate for the volume. We just found a rate for a height, so it will just be feet, not cubed. So just feet per minute.